So this is our third week. Okay. So I hope you guys have seen the lectures for week 3. So I will start from where we left off. So I will wait for 2 to 3 minutes for other students if they come, and then I will start. So you guys went through the lecture from week 3? So we will start now. Okay, so I will first share my screen. Okay, so you guys are able to see my screen, right? Okay, so now this is the third week. So in the last week we were discussing one problem, which is how to find the distribution function of a function of a random variable. So we are given the fx, the PDF of a random variable, and then we need to find the distribution function of y, which is x square. Okay, so we were solving this question. So I need to share another screen now. Okay, not this one. Yeah. Okay. So the problem was this fx was given as 1 by 2 e to the power minus x. It's for all x. Belonging to R. Then y is given as x square. So we need to find the distribution function for y. Okay. So for this, we started it like this. So for the distribution function, you can find either the CDF or the PDF. Okay, the cumulative density function or the probability density function. So here we are looking at the CDF. Okay, so f capital Y small y is equals to probability of capital Y less than equals to small y. Now capital Y can be written as x square, and we can again write it like this. Okay. So now this is nothing but a integration of fx dx from minus root y to plus root y. Okay, and when we solve this thing, it will be, when you put the values, that is e to the power minus x by 2 dx. So for negative, this will become minus x by 2 from minus infinity to 0 plus 0 to root y e to the power x, sorry, this will be positive. For x less than equals to 0, it will become minus x, and here is one more minus, so it will become plus x, and this will become minus x by 2 dx. So when you solve this, it will come out to be 1 minus root y. Okay, so this is the cumulative density function for y, and after differentiating it, you will get the probability density function. So that will come out to be e to the power minus root y divided by 2 root y. You can try this, and you can check that by differentiating this term you are getting this thing. This will be the PDF. So whenever we are asked to find the distribution function of any other random variable which is written in the form of other random variable, so here y is the random variable which is written in the form of a function of another random variable, which is, let's say, fx. It can be any function of the random variable. So for this, if we want to find the distribution of this y, then we can either find a cumulative density function, or we can find the probability density function. Both are okay. Okay, so generally cumulative density functions are quite easier to find, because we can directly integrate it by putting the limits of y. Okay, we can change, like, so here we did something like this, right? And then we wrote this y in the form of x, and then we wrote it like this. So now it is nothing but, this is the probability of x, So it is the probability of x from minus root y to root y. So this can be solved by integrating fx dx from these limits. So you can directly, the fx, you can directly put the fx and then integrate it and put the limits from minus root y to plus root y, and then you are able to find this cumulative density function. Okay, so it is a much easier approach. So I can share my entire screen. I'm having some trouble in sharing my whole screen, so I need to switch my screen from the presentation to my Jamboard. So in the today's class, we are discussing the problems related to the topic mean and variance, high order moment inequality, and generating functions. Okay, so first I will summarize all this topic, all the formulas that we need to solve the problem questions. Okay. So we will start with the mean. Or you can say expectation. So I will okay, so I will start with the formula itself. So for discrete function, this expectation or mean will be summation of xi's, summation over I, probability that x is equals to xi. For continuous, expectation will be from minus infinity to infinity x fx dx, and these will exist, these both things will exist only when this will exist only if this this exists, or this has a finite value, that this is summation over I. So if this thing is valid, then only the mean of our function x will exist, and that will be equal to this thing. Similarly, for continuous, the expectation will exist only when this thing is a finite quantity, not equal to. So for discrete random variable, if this thing exists, if this is a finite value, then only the mean will exist. And for continuous, if this value has a finite value, then only the mean for continuous random variable will exist. Okay. So these are the formula, and these are important. Yeah. Yeah. Acha. Okay, so it is like this. Like for example, uh, we have two. We are. Let's take the example that we are tossing uh, three coins randomly. Okay, and simultaneously. So output of those can be heads, 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 tail, heads, and something like this. And let's say that x is the number of heads. Okay, so this is now the random variable. So x can be 1, x can be 0, x could be 1, x could be 3, and x could be 4. Okay, so these are only 4 possibilities for x. Then probability that this x is equals to this. So this xi is here, it is 0. For this is it is 1. These are xi's. This is x1, x2, x3, x4. And then all these have some values, right? So there are total 16 combination, and only one of them will have 0 heads, which is tail. So probability here becomes 1 by 16. Okay, so here x1 is 0, and probability that x is equals to x1 is 1 by 16. So so you can check that it will be 2 to the power and n 8. So it will be 8. So it will be 1 by 8. Okay, so it is the number of heads. So there is only one possibility that we get 0 heads, that is tail. We get all 3 as tails. Like, so this value is 0, but probability that this outcome will come is 1 by 8. So there is, sorry, क्या बोला आपने? What was your question? Tail, head, right? So here, like, it depends on our random variable. So here it is number of heads. So this is 1, right? Here the number of head is 1. Another cases where heads is 1 is this thing. These are the other possibilities, right? So it will be 3 by 8. Okay. So let's suppose there are 2 coins. So outcomes can be head, tail, tail, head, and tail. Let x is number of heads. Possibilities is x can be 0, x can be 1, x can be 2. X will be 0 only when we get tail. X is equals to 1 when we get head, tail, or tail, head. X is equals to 2 when we get heads and heads. So what is the probability that we will get tails? Why it is 0? What is the Don't look at this thing. Look at this thing. This is your state space. This is your space. Okay, so there are total 4 elements in your space. Okay, and I am asking the probability of getting this one. So So this will be 1 by 4, this will be 2 by 4, and this will be 1 by 4. Okay, did you understand this? Okay, so try to read more, I guess. So you here they like this 0 does not represent that that it is in the state space. State space is combination of the elements of the outcome of our experiments. Random variable is something that we are associating our experiment with some conditions. Okay. Yeah. So what is चलो ठीक है, forget about this thing. Okay, forget about this thing for once. Okay, just look at this state space that we have. If we tosses 2 coins, then there are the outcomes. Possible outcomes are heads, head, tail, head, and tail, right? Now what is the probability that you will get an output tail? Okay, so what is the probability that you will get this? How 1 by 2? Here we are tossing 2 coins, we are not tossing 1 coin. When we tosses 1 coin, then there is the probability that this is 1 by 2, this is 1 by 2, right? So he is asking that like, so when I am saying that they expect, so I will explain. So he is asking that what is this x size here? Okay, so he is asking about this xi. Okay, so what is this xi? So I am explaining that what is a xi with the help of example. Okay, so Ravi Shankar, I request you to please like These are very basic things, so you should know these things. So, because there is no, I cannot. So there are 4 elements in our state space. Okay, this is your state space. What is the probability that you will get this one? So it is the number of times it appears in your state space, which is 1, and upon the length of your the total number of elements in the state space, which is 4. Right. But I cannot understand why it is 2 by 4. So here we are not tossing one coin and then we are tossing the another coin. The experiment is we are simultaneously tossing 2 coins. So state space has changed. Here the state space, I am writing the state space, like what is the what are the possible outcomes of the experiment when we tosses 2 coins. If you toss 2 coins, what are the possible outcomes? These 4 are the possible outcomes, right? So you just need to look at this thing because your experiment is about this thing. Now what is the probability? If you want to get 2 tails, the probability will be 1 by 4. If you want to get 1 heads and 1 tail, then probability will be 2 by 4, because there are 2 elements which are there are 2 elements whose output is 1 head and 1 tail. Here also it is one head and 1 tail. So this will be 2 by 4, and probability that you will get 2 heads, it will be 1 by 4. So random variable is something like, it is a function. Okay, so here the random, so that's what I was saying, that here random variable, if random variable is number of heads, then x will be 0, the possible state space will be tt, x equal to 1, that which means the number of heads is 1, possible states will be head tail and tail head, and x equals to 2 means that we need to have this heads. So probability associated with tails is 1 by 4, this is 2 by 4, and heads is 1 by 4. Yeah. Okay. So so there are few remarks related to mean. The mean value of a constant function is the constant itself. Okay. Now if we talk about this thing where a and b are both constant, then expectation will be a ex plus b. Okay. Then if probability that x is greater than equals to 0, and if this expectation of x exists, then expectation will be greater than equal to 0, because it is x, probability x x is equals to small xi, and here we are talking that xi's are all are greater than 0, and we know that probability is between 0 to 1, so that's why this expectation is always greater than 0 whenever the x is greater than 0, like this probability is 1. So we are talking that if our x is positive, if it's a positive value, then expectation will also be positive value. Okay, and another thing is, if there is a function y equals to gx where x is a random variable, then expectation of y is equals to it will be summation I gx probability x equal to xi for discrete, and for continuous this will be okay. So we can find the expectation of this variable which is written in the form of function of a random variable. Okay, so these are all the formulas. You can go through their proofs by your own to understand them more better. Okay, so we will discuss few problems related to these. So this is for the mean. Similarly, there is another thing which is second moment, which is variance. So expectation was summation xip and for continuous it was fx dx x fx dx from minus infinity to infinity. So now variance is so it is the expectation around the mean. Okay, this is the moment around the mean value, which is mu. So if you open this will become 2x mu, which can be written as expectation of x square plus expectation of mu square minus 2. This will be expectation of x into expectation of mu. Okay, so this mu is a constant value because it's a mean. So this will, after simplifying this, this is constant, this is constant. It will become x square plus expectation of mu square minus, this is also mu, right? Okay, so this can be written as 2 mu, and this is constant, so it will also written as mu. This is mu square is constant, so we write it this like this way. It will become, or we can say this mu is expectation of x whole square. So this is expectation of x square, this is expectation of x ka whole square. Okay, so this is variance of x. And expectation of x square is nothing but it will be x square fx dx minus infinity to infinity for continuous and for discrete it will be x square probability x equals to xi summation over I for discrete random variable. Okay, so now there are few remarks. So one is that if x is a continuous random variable, okay, and the uh, CDF of x exists, okay, and expectation of x also exists, then expectation of x can be written as 0 to infinite 1 minus fx dx minus fx minus infinity to 0 dx. So where this fx is integration of fx dx, okay. So variance of a constant quantity is 0, okay. You can try to prove this one at your own. And probability that x is equals to constant, okay, if x is a constant value, then expectation of x will be this constant value alpha, but variance of x will be 0, okay, because variance of a constant quantity is 0. And variance for ax plus b, it is nothing but a square variance x, and for the constant value it is going to be 0, so variance of ax plus b is a square variance x. So what is variance and what is a mean value? Let's suppose we have some distribution, okay, this is mu. So it is an example, it is not always be the situation. So this is the mean value. Mean value means that where maximum outcomes are surrounded at surrounded at this quantity, the maximum of the probability of occurrence of the possible outcomes are near to this mean value. It has the maximum outcome, okay, maximum possible yeah. Yes, but not always it's a average value. It is not always the average value. So mean is so it is not the maximum probability, it is just that the maximum possible outcomes of an experiment are near to this mean value, are closer to this mean value, okay. And variance will be the variance will tell that the other outcomes, all the outcomes, how far are they from their mean values, okay. So this is the mean value, but this point is far from this mean value, right? This is something x and this value is x minus mu. So while finding the variance, we are calculating the expectation of this, right? X minus mu. Similarly, here it will be x minus mu. This is, let's say, x2, this is x1, this is x1 minus mu, this is x2 minus mu. That's why we are taking the square. We are taking like what is the how much the values are deviating from their mean value. Okay, so here we are saying that there is only one possible output of an experiment, which is alpha. X is equals, the probability that x is equals to alpha is 1, which means that this is alpha. So probability, this is the probability x, this is x. So there is only one probability here, that it is equals to 1. So the mean value will be 1, and there are no other possible outcomes of the experiment. That's why the variance is 0. Okay. Look at another example. So let's suppose this is 1 by 4. No. So now this is x1, x2, x3. Let's say x1 has probability 1 by 4, x2 has this probability 1 by 4, and x3 has probability 1 by 2. Okay. Now there are 3 quantities, and mean will, and let's suppose this is 1, this is 2, this is 3. So probability that we get 1 is equals to 1 by 4. Probability that we will get 2 is 1 by 4. Probability that we will get 3 as outcome is 1 by 2. So what will be the mean for this value? It will be 1 into 1 by 4 plus 2 into 1 by 4 plus 3 into 1 by 2. So this is nothing but 3 by 4 plus 3 by 2. It's 9 by 4, which is 2.25. So our mean will lie somewhere here. This is the mean, and now the variance will be different. This is the mean value. Okay, 2.25. This is the mean value, and our variance will be deviation of these points from this mean value. So this is one deviation, this is another deviation, this is the another deviation. There are 3 possible deviated out. So this is the x3 minus mu, this is x1 minus mu, and here it is x2 minus mu. So by squaring and adding them, and then like multiply them with the probability of their occurrence, we will get the variance. That what is the possibility that our outcome will deviate from the mean value. So this indicates the variance. So just for now, just try to remember all these formulas and try to read about like what is the mean, what is the variance. Then you will understand more about the questions. Okay, and you need to build, like we can teach you, but you need to think about these things by yourself. Then only things will become more clear. Okay, so I will also want to talk about some higher order moments. So this mean was first order moment, this variance is second order moment, and now we will talk about high moment orders where n will be greater than 2. Okay, so it will be denoted by mu n where n is greater than 2, and we will find its value by doing this thing. Okay, so this is around the mean, this moment is around the mean value. Okay, and if you want to calculate the this moment around the origin, then this mu will become 0, and you can find it like this, x to the power n. Okay, so this will be the moment around origin, and this will be moment around mean. So so these moments will help you in finding the lower and upper bound of any data. So when you have some random variables, right, you do not know their distribution. Okay, but with the help of these moments, these first order moments, mean, variance, all this high order moments, you can find the lower bound and upper bound. Lower bound is like what this is probability, this x-axis is the random variable x. So this is some x1, this is x2. So let's suppose that we have a function someone between this x1 and x2. So from with the help of these moments, we can find what is the value of this x1, what is the lower limit, lower bound, like before which there is no function possible. Okay, so there will be no existence of the random variable before that point. So this will be the lower bound, and this will be the upper bound, that after which there will be nothing, there will be no random variable. Okay, so it is defined only in this these two numbers. So this will be the lower bound, this will be the upper bound. Okay, so there are few moment inequality theorems. which are used here. So first is Markov's inequality, which says that if x is a random variable, okay, and if probability that x is greater than equal to 0 is 1, this means that random variable x is always greater than 0. It is defined from 0 to infinite. Before it is 0, there is, so it is not defined before 0, okay, it is defined from 0 to infinity. So this means that probability that x is greater than equal to 0 is 1, which means that x is always it is defined for x greater than equal to 0. So if this is the case, and that this ex exists, then for all t we can say that probability that x is greater than equal to that t is equals to greater than equal to, not greater than, is less than equal to expectation of x by t. Okay, so this is very important inequality, very important. This helps to find us the lower bound. Okay, so I have an example over here. So let's try to prove this theorem. Okay, so what we are trying to prove, that x greater than equal to t is less than equal to expectation of x by t. Okay, so it was said that probability of x is greater than 0 is equal to 1. So now let's define another random variable y, which is equal to 0 when x is less than t, and it is equal to t when x is greater than equal to t. Okay, so it is for any fixed t. Okay, so we are defining that whenever this x is less than t, y equals to 0, and if x is greater than t, then the value of y will be t. Okay, now probability that y equals to 0 is probability that x is less than t, and probability of y equals to t is that probability of x is greater than equal to t, right? So now when we find the expectation of y, this will be, so 0 into probability that y equals to 0 plus t into probability that y equals to t. So which can be written as this ey equals to 0 into p y equals to 0 plus 1 into p y equals to t. It can be, this will be 0, so we are not bothering about this. This can be written as that probability that x is greater than equal to t. Okay, we know that x is greater than equal to y. How is that? Because if probability these things are same, that y is equal to t and x is greater than equal to t, so which means that x will be greater than equal to y. So from this we can say that expectation of x is also greater than equal to expectation of y, because this is always a positive quantity and this is also a positive quantity. Okay, so expectation of x is greater than equals to expectation of y. So we can put the value of ey, which is, here it is t, t into probability of y equals to t. So Ex is p equal to t or greater than probability of x greater than equal to t from here. So I'm moving a little fast because I want to solve few problems. So Ravi Shankar, you want to ask any question? Yes. T is the, we defined y as this 0 if x is less than t and y is equal to t if x is greater than equal to t. T is a fixed value. T is a fixed value. Okay. So we defined a y which is 0 if x is less than t, and if x is greater than equal to t, then this y will be t. So if we want to find the, so probability that y is equal to 0 is probability that x is less than t, and probability that y is equals to t is probability that x is greater than equal to t. So if we want to find the expectation of y, so from the definition of expectation, it will come out to be 0 into probability that y is equals to 0 plus t into probability that y is equals to t. So this will be 0. This probability of y equals to t can be written as x greater than equal to t, right? This is expectation of y. X is greater than equal to y, which implies that expectation of x is greater than equal to expectation of y. So from here we can rewrite it as this. From this equality and from this inequality, we can say that Ex is greater than equal to probability x greater than equal to t. So which is this Markov's inequality. So I'm just going to discuss one more inequality and then we will solve few questions. Another theorem is Chebyshev's inequality. So it says that if x is a random variable with expectation is equals to mu and variance equals to sigma square, okay, these are given, okay, then for any epsilon greater than 0, probability that x minus this is some constant greater than epsilon is less than equal to expectation of x minus c square by epsilon square. So this is another inequality. You can put this c equals to mu also, then this will become probability that x minus mu is greater than epsilon is variance of x by epsilon square. Okay, because expectation of x minus mu square is variance x, and this will be variance x by epsilon square. Okay, so these are the few formulas you need to keep in mind when you are solving the questions, and these few inequalities. So we will try to solve some question, and then I will again try to define some after this I will try, if we have time, then we will discuss some more theory and problems. So I am stop sharing this. So you can see the question on the screen, right? So there is a continuous random variable, okay, and we are given the probability density function, and we need to find the expectation for this function. So try to solve this question. We need to find the expectation. I'm giving you 5 minutes of time, and you try it your own, and then I will explain this. So you need to revise all the formulas for the integration for solving these questions. So for the starting, try to find the value of k, small k. So you know the PDF, which is kx square e to the power minus x plus 1. So you can integrate this from minus infinity to infinity, and you will and equate it to the 1. Okay. So I will give you a hint. So and x is greater than 1. So you need to find the value of this k first. So this fx dx from minus infinity to infinity is equal to 1. This we know, and this is defined from 1. Okay, it is greater from 1 to infinity. So this will become fx dx 1 to infinity, which is equals to 1. So try to solve this thing first. From here you will get the value of k. So first I want to know what is the value of k you guys are getting. Okay. So this integration is quite long, I guess. So it will, if like if you forgot the basics of integration, then you need to revise, because the such questions will be asked in the exams. So it is k x square e to the power minus x plus 1 to infinity dx equals to 1, which can be written as x square e to the power minus x plus 1 dx equals to 1 by k from 1 to infinity. So this x square e to the power minus x plus 1. So when you solve this integration, it will come out to be so I am writing it. So this is just the, like, it is the one kind of problem that you need to become fluent at. So this will be the integration value, then you will put the value from 1 to infinite, which is equals to k. So now try to solve this thing. This is the integration. Just you need to put the values 1 and infinite, and then equate it to 1 by k. Tell me what is the value of k from this equation. You just need to put first infinite and then you need to put 1. Anyone? So this value comes out to be minus 1 by 5. Okay. Now when you know the value of k, your fx will become minus x square e to the power minus x plus 1 divided by 5. Okay. Now you know the fx, right? There is no constant in this term now. Now expectation is x fx dx from 1 to infinity. Fx is x square e to the power minus x plus 1 divided by 5. This is negative, right? Dx, which becomes minus x cube e to the power minus x plus 1 by 5. This will be 1 to infinite. So when you solve this, you will get 16 by 5. This is the answer. So try to see the integration, try to integrate it, and then check whether you are getting the 16 by 5 or not. Okay. So we'll move on to the next question. So here we are, x is a continuous random variable and we are given the probability density function, and then we are given the this y, which is the function of x. Okay, and then we need to find the expectation of this y value. Okay, so just try to solve this and I will be back in 5 minutes.
protein powder.
So this is the question, right? We need to find the expectation of y where y is mod x. So y is equal to x when x is greater than 0, and it is equals to minus x when x is less than 0. Okay, these two things are clear, right? Now if we want to so expectation of y is some function of x, so we can write the expectation as gx fx dx from minus infinity to infinity. Okay, gx is nothing here but function of it is the function that maps y with x. So y is equal to x for x greater than 0, and it equals to minus x for x less than 0. So this will open as minus infinity to 0. This will be minus x fx dx plus 0 to infinity y is equals for greater than x for x greater than 0, y is equals to x fx dx. And fx also is different for x greater than 0 and x less than 0. Okay, fx is e to the power x by e to the power x for x less than 0, and for greater than 0 it is e to the power minus x by 2. Okay, so now we will put these values. So we will put here we will put e to the power x by 2, and here we will put e to the power minus x by 2, because the function is changing from minus infinity to 0 and from 0 to infinity. Okay, so it will become from minus infinity to 0, this will become minus e to the power x by 2, and then add dx plus 0 to infinity x e to the power minus x by 2 dx. So on solving this whole equation, you will get 1. Okay, this value comes out to be 1 by 2, and this value comes out to be 1 by 2. Okay, so this is nothing but the when you will this just bring these minus 1 by 2 outside the integral, and then integrate this thing, and this is, like we know the output for this. So x ex dx is equals to x ex minus e to the power x. Then you put this from minus infinity to infinity, and this minus 1 by 2 will be outside this bracket. And similarly, x to the power minus x is, so I will just solve this. So this expectation will be minus x e to the power from minus infinity to 0 plus 0 to infinite x to the power minus x by 2 dx. So this will be minus 1 by 2 x to the power x into e to the power x minus e to the power x minus infinity to 0 plus 1 by 2 minus x e to the power minus x minus e to the power minus x from 0 to infinite. So on solving this, you will get this value will be 1, this value will be 1 by 2, this whole value will be 1 by 2, so your answer will be 1. So moving to the next question now. Okay, so first we will first we will discuss about this moment generating functions now. So there are three moment generating function. First is probability generating function. Second is moment. These are generating functions, non-moment. It is moment generating function is type of generating function. And third is characteristic generating function. So first is probability generating function. So it is nothing. Let's suppose there is a random variable and it is non-negative. Non-negative integer valued random variable, okay, with probability x equal to k. Pk is denoted as probability of x equal to k, where k is 0, 1, 2 and so on. So then this generating function, this probability generating function is given by this notation, capital G x s, where k summation over k from 0 to infinite is probability x equal to k into s to the power k, where mod s is equal to 1. So for this mod s equal to 1, this quantity will converge. Outside this mod s equal to 1, we don't know whether it converges or not, but for mod s equal to 1, this value will converge. So we will get some value for this generating function. Okay. So there are few remarks for this probability generating function. That is that for value of s equal to 1, the moment this probability generating function is 1. Okay. Second is, this is nothing but expectation of sx. Okay. And another remark is that probability that x is equals to k, it is 1 by k factor gx 0. S value of s is 0 here, where k is equals to 1, 2, 3 and so on. Second generating function is moment generating function, and it is denoted by mxt, and it is the expectation of e to the power tx. Okay, so when we open this term, it will come out to be this. T square by t factorial into e to the expectation of x square plus t cube by 3 factorial expectation of x cube, and so on. This series will also converge to something. Okay. So this is also a moment generating function. This is a moment generating function. So there is few remarks for this. So if there are two random variables x and y, and if moment generating function of these two random variables are equal, then distribution of x and y are also same. Okay. And this, the expectation of nth order of x is equal to differentiation of this moment generating function by nth time at t equals to 0. This is the another important, very important remark. So this is for this expectation of x will be nothing but mxt by dt at t equals to 0. Similarly, expectation of x square is d2 mxt by dt square at t equal to 0. Okay, so this is very important remark. If you do not know the mean of mean and variance of your data, then but you know the moment generating function, then you can easily found the expectation and variance, and from this expectation and variance you can easily found this moment generating function. So we try to see few problems for this question, for the moment generating functions. So here is this question. So we are given the moment generating function, and we are asked if mu is the mean and sigma square is the variance of x, then what is the value of p, mu minus sigma, that x will range from mu minus sigma to mu. Okay. So we are given so this is the moment generating function we are given. So we know that expectation of x is equals to mu, and we also know from the previous conclusion that expectation of x is nothing but differentiation of this moment generating function, first order differentiation, and then putting this value t equals to 0. So if we differentiate this moment generating function, it comes out to be this value becomes 0. This will be 1 by 4 e to the power t plus 2 by 3 e to the power 2t plus 3 by 4 e to the power 3t. and then put this t equal to 0. So we will get 1 by 4 plus 2 by 3 plus 3 by 4. So this will come out to be 5 by 3. Okay, so we get the value for mean, expectation value. Now we will find the variance. Okay, we find the sigma square is nothing but variance. So we know this expectation of x square is nothing but 2 time differentiation of moment generating function and then putting the value to t equals to 0. So by putting this, just so this will be 1 by 4 plus 4 by 3 plus it is 9 by 4. This comes out to be 10 by 4 plus 4 by 3, which is, this will be 5 by 2 plus 4 by 3, 23 by 6. Okay, sigma x square is expectation of x square is 23 by 6. We know that variance of x is expectation of x square minus expectation of x whole square. So on solving this, we will get that variance is nothing but it's 19 by 18, which is somewhere it's just a minute. It's 19 by 18, which is something around 1.0027, somewhere around this thing. Okay, so now again when I rewrite this moment generating function, then what we can see, what we can infer from this. So we know that it is expectation of e to the power xt, right? So how we can write this? E to the power xt, probability that x is equals to 0. Okay, because here we have this e to the power 0, we can say 0 into t. So we can see that here x is equals to 0 plus e to the power xt into probability that x is equals to 1, because here the x is equal to 1 into t. Similarly, it is this is t, right? This is 0 into t. Here it is 2t, where probability is x equals to 2. Similarly, e to the power 3t, where probability x is equals to 3. So these values, these are nothing but the probabilities that x is equals to 0, x is equals to 1, x is equals to 2, x is equals to 3. So we can define this, distribution function for this random variable now, right? So for 0, the probability is 1 by 6. For x equal to 1, the probability is 1 by 4. For x equals to 2, probability is 1 by 3. And for x equal to 3, the probability is 1 by 4. Okay. So given this, you can find the moment generating function, which is nothing but e to the power xt. So if you rewrite this by putting these values, So it will become e to the power 0 into t into 1 by 6 plus e to the power 1 into t into 1 by 4 and so on. So you will get this. From this you will get this moment generating function by putting it through this formula, e to the expectation of e to the power xt. Okay. So now we are asked that what is the probability that x will lie from mu minus sigma to this mu. So mu is equals to 5 by 3 and this value is 5 by 3 minus root 19 by 18. Okay. So this is higher than 1. This will be 1 point something something. So I will start from the new page. So the probability that x lies between mu minus sigma to mu. So mu is 5 by 3 which is around 1.666 something, and this sigma square we found out to be 19 by 18. So we found that sigma is equals to 1.027, somewhere this quantity. So mu minus sigma will be around something 0.5, around 0.5 or 0.6. Okay, so it will be somewhere between 0.5 to 0.6. So we just previously defined that these probabilities, this is a discrete event and we defined the probabilities like this: 1 by 4, this be 1 by 3 and this is again 1 by 4. So now this, what is this thing asking? It is asking that probability that x is between 0.5 to 1.66. So the only possible value in our sample space for x in the range 0.5 to 1.66 is this 1. So the probability that our x lies from 0.5 to 1.66 is that the is equal to the probability that x is equals to 1, and the probability that x is equal to 1 is nothing but 1 by 4. Okay, so these moment generating function will tell you a lot about the actual distribution function. Okay, so this is the another example for the moment generating function. So just try to see, first try to find the distribution of the random variable x from this moment generating function. अरे वो यश ने कुछ फ़ोटोज़ भेजी होंगी, देख लो, वो बार बार भेज रहा है. So this is the question, that moment is given as a plus b into e to the power 2x plus c into e to the power 4t, and expectation is given, variance is given, and we are asked what is the expectation of 2 to the power x. Okay, so as I told you earlier, that what is this moment, it is e to the power xt. So we can see that when we see this function, it is a plus b e to the power 2t plus c e to the power 4t. So there are only three values, it is summation. Okay, so I am audible now, right? I was on mute. So this is the expectation of e to the power xt, which can be written as summation of probability that x is equal to x into e to x is equals to xi t, right? So by comparing this, I say x equal to x1 into e to the power x1t plus p x equal to x2 into e to the power x2t, and so on. So if we compare this and this, what we get, that x for x1 equal to 0, we have the x1 equal to 0, we can so this is a plus b into 2 e to the power 2t plus c into e to the power 4t. So this is nothing but probability that x is equals to 0 e to the power 0 into t. So this will become 1, and this a is this probability. Similarly, this is probability that x is equals to 2, or this is e to the power 2t. So this is nothing but b. Similarly, probability that x is equals to 4 e to the power 4t. So here this is nothing but c. Okay, so now you can find this moment. So from this moment function, you get your distribution. That is nothing but x is 0, 2 and 4. These are the only three quantities in your space, sample space, and the probability associated with 0 is a, probability associated with 2 is b, probability associated with 4 is c. Okay, and you also know that this expectation of x is equals to 3, and also this expectation is equals to differentiation of this mxt function for t equals to 0. So when you solve this, you will get this a plus 2b plus 4c. This 3 is equals to a plus 2b plus 4c, and this variance of x is also given as 2, right? So second thing you can calculate is the expectation of x square, which is nothing but d2 mxt by dx at t equals to 0. So from here you will get the new equation. So this this ex square come out to be a plus 4b plus 16c. Now you know this variance of x is nothing but expectation of x square minus ex whole square. This is 2. This came out to be a plus 4b plus 16c, and expectation of x is given 3. So 3 square, which is 9. So we brought this 9 here. So 11 is equals to a plus 4b plus 16c. So there are three equations. This is one equation. Another was a plus 2b plus 4c, and another is a plus b plus c is equal to 1, because these are the probabilities and sum of all the probabilities is equals to 1. So by solving all these three equations, you can find the value of a, b and c. So if you find the probabilities of a, b and c, you will get the distribution of the function. For 0, 2 and 4, you will get the probabilities. Okay. So this came out to be 1 by 3, b came out to be 0 and c came out to be 2 by 3. Now we need to find the expectation of e to the power 2x. So it is nothing but 2 to the power 0 into 1 by 3 plus 2 to the power 2 into 0, this is the probability, plus 2 to the power 4 into 2 by 3. So this is 1 by 3 plus 0 plus 32 by 3. So this is 33 by 3 came out to be 11. Okay. So that's why these moment generating functions are quite important thing. Okay, so today I'm going to discuss these 4 questions, and I request you all to go through this week 3 lectures around 2 times, because this is a difficult concept, and then try to see this tutorial again, that how do I solve the questions, and if you have any doubts you can ask in the next session, and try to solve as many questions as possible. So if there is anything you people didn't understand in this tutorial, you can ask me, because it's already 7:50 and I need to cover 1-2 more things, but I don't think I will be able to cover those things. So you just need to remember all the formulas, that how this moment generating functions are related and how the mean and variance are related. So this will help you in the future things. So try to understand, try to go through the proofs of all these remarks which I taught you today, and then try to remember all these formulas and revise your this concepts of the integration, because in the exams you will get difficult integration problems also. So try to solve those, because it's e to the power x functions are very important. Thus distribution functions are very important. So any of you have any doubts? Okay. Okay, then I will stop I'm ending the session. Okay, then. See you on the next week.